Alright, this is section 9.8. We're talking about higher derivatives. And so if you take a original function and you take its derivative, you're talking about the rate at which the original function is changing. But if you take the derivative of that, which is called the second derivative, you're looking at the rate at which the rate of change is changing. One example of multiple derivatives is if you have the original function is a position function, the first derivative is a velocity function, and then the second derivative is acceleration function. So you can use multiple higher order derivatives to explain different situations. So they ask you to find the second derivative here, so you take the first derivative and then take the root of that. They ask you to find the second derivative here, so you take the first derivative and then second derivative again. And this is how you can write the second derivative. Here you've got square root of 2x minus 1, so they want you to find the second derivative. So you can write that with a 1/2 power and bring the 1/2 out front and subtract 1 from the exponent times the derivative of what's inside. 1/2 times 2 is just 1, so you just get this guy. And now when you take the root of that, you bring the 1/2 out front and subtract 1 from the exponent times the derivative of what's inside. 1/2 times 2 is just 1, and so you got a negative times this guy to the negative 3/2, and you can cross the fraction bar with that guy and make it a positive 3/2, and you can write it as square root of that item cubed. And here's the way in which you can write the third derivative 3 different ways, and fourth derivative that way as well. Example 3, here's the original function, its derivative, second derivative, third derivative, and finally fourth derivative. This one talks about subscribers, and they ask you to find the first derivative, so you just take the derivative there. And then they ask you to find the second derivative, and you get this guy here. Now they ask you where does the second derivative equal 0. When you set it equal 0, you can solve it, and you get t equals that. And that's in the year 2009. And then D says, for the instantaneous rate of change, in 2005 and 2018, so that's 15 years after 1990 and 28 years after 1990, so you're checking out C prime of 15 and C prime of 25, 28, and you get these two numbers there. And then the second derivative, same thing with 15 and 28, and you get these two answers here. Then you can say the number of cell phone subscribers increased at a rate of 0.310 billion per year, but the rate of change decreased at a point of 0.0395 billion per year. In 2018, it was increased, but at a decreasing rate. Example 5, they ask you how fast is this guy changing at 1, so you take the first derivative and plug in 1. And the rate at which the change of f is 24 y units for each x unit. How fast is f prime changing? So you take the second derivative and plug in 1, and now you can say the rate of change of the first derivative is 66 y units for each x unit per x unit. Notice it's per unit because it's the second derivative. Then C says, is f prime increasing or decreasing at 110? Well, because f double prime is positive, f prime is increasing at 110. If you have the position function for a given function, the derivative is the velocity and the second derivative is acceleration. This is the position function. And they ask you to find the acceleration. So you take the derivative, and that's velocity. Take the derivative of that, and that's the acceleration. Alright, find the second derivative, so you just take the derivative and take the derivative again. You rewrite it using these exponents, and then take the derivative and take the derivative again. This one, find the third derivative, so you take the derivative 3 times. And this one, it's better to write it as x to the negative 1, and then you can find the derivatives a lot easier, and then you can clean it up with a positive exponent there. 17, find the fourth derivative. So you take the first, second, third, and finally the fourth derivative. Same thing with this one. You want to write the square root of x as x to the 1/2 and take the derivative. Again, again, and finally again, and you can clean it up by writing it with a positive exponent if you want. Okay, this one says find first and second derivatives, so we do that. This is graph them, and f is here, f prime is here, and f double prime is there. So they ask you identify where the second derivative equals 0. Second derivative equals 0 here at 1. Identify where the second derivative is positive, that's greater than 1. Where it's negative is less than 1. D, identify where the first derivative, that's this guy here, has a maximum or minimum point. It has a minimum point at 1. And identify where the first derivative is increasing, well that's greater than 1, and decreasing less than 1. And then E, where when f has a maximum point, well where's f? F is this guy here. Its maximum point is there. What is its, is f double prime positive or negative? Well, f double prime is negative. Now where does, if f has a minimum point, which it does, right there, is x f double prime positive or negative? Well, f double prime is positive. Okay. 35, it'll give you the revenue and ask you to find the rate of instantaneous rate of change of the marginal revenue. So you take the first derivative, and the instantaneous rate of change, the marginal revenue is the first derivative, then the instantaneous rate of change in the marginal revenue is the second derivative. Here's your revenue. When you take the first derivative, you get marginal revenue, or R prime. When you take the second derivative, you get marginal revenue prime, or R double prime. And you get this. Now they ask you to check it at 100. Plug in 100 and you get $0.40 per unit. And 37, this is a function in terms of m, and the c is simply a constant. And so you can think of this as m squared times 1/2 c minus 1/3 m. Okay, so when you go to take the derivative, you're talking about using the product rule. So you can think of the first guy as m squared untouched times derivative of what's inside. What's inside, that's a constant, so that's 0. Derivative of this guy is just minus 1/3. Plus the second guy untouched, right? Second guy untouched times the derivative of the first guy, which is 2m. Now when you multiply those two, you get this. Multiply each one of those, you get this. And minus 1/3 minus 2/3 gives you minus 1. And so you get cm, and you get minus 1 of the m squareds. And you can take the second derivative of that, and you just get c minus 2m. And they say, which order derivative of reaction gives the rate of change of sensitivity? Well, the first derivative was sensitivity. The second derivative is the rate of change of sensitivity. So it's the second derivative is your answer there.